What is phase difference? Well, I thought as an exercise, this could be really, really useful for you. Sketch a sine wave and label all of those things. This will help you understand how we talk about phase difference and why we use the language that we do. Sine is a function which looks like a wave, so it's really handy to be using this more mathematical language to describe the shape and properties and behaviour of a wave. A phase difference tells us how far out of step 2 points are when they're on the same wave. And it's best done by just looking at it. So the book shows a graph, and I'm actually kind of worried that you will have copied this in a really imprecise way. So let's have a look. I've used this to help sketch it, and I'll give you some tips on how best to draw waves as we go through. This should match the sketch in the book. It's got kind of 2 1/4 wavelengths on it. So there's 1, 2 1/4, and there are 3 other waves it asks you to sketch. We'll do them one at a time. B is oscillating in phase with A, but it has a smaller amplitude. If a wave is in phase, that means that its peaks are in the same place, the zero crossings are in the same place, the troughs are in the same place, and in this case it's got a smaller amplitude. It doesn't have to, but if it didn't, it would be basically the same wave. The language that we use to describe it is, it's got a phase difference of 0 degrees. It's in phase. The next one is 180 degrees out of phase. If I go to the start of my wave and I count along the x-axis half a cycle or 180 degrees, and I just take that and push it along, I literally just imagine this shunted along by whatever fraction of a cycle. You can draw the rest of this bit later, take the beginning, shunt it forward, and there you have it. That's how you do phase difference. And as a pro tip for when you're drawing waves, don't just try and freehand it. You know, I did this on Excel point by point, but when you are actually sketching a wave, put across here, put across here, put across here, etc., and then join the dots. It's the easiest way to do it. Do not try and freehand draw a wave in a task like this. You'll be penalised for your accuracy. It won't be accurate. There's lots of different terminology for this, but basically it's half a cycle out. 180 degrees. Sometimes we use the word antiphase to describe that as well. You might see phase differences quoted in radians. Maths will have taught you radians and you find them quite easy. If you're not sure on them, ask me. If enough people are asking about radians, I'll do a quick video on how to do them. The next one represents a wave that is 1/4 of a cycle, pi/2, out of phase. We take our original wave, just push it forward by 1/4 of a cycle. Plot your points one by one, and then join the dots. It's as simple as that. The phase difference, as we said, specified in the book, it's 1/4 of a cycle, 90 degrees, or pi/2 radians, half pi. Make sure that what you filled in off the VLE is accurate and it's not just a pretty picture of some waves. This is supposed to be done sequentially as an exercise, and if you've just copied out this mess, there is no way it'll make any sense to you. Why don't you get a piece of paper and start it again yourself and just check that you can do those tasks. There are a few exercises at the back of the book which consider phase difference as well. Certainly in the under topic questions, you are usually asked to sketch, and so accuracy is key. That is phase difference. How far out of step 2 points are on a wave. I think, like most language, phase difference is better done by example than trying to unpick this definition. Just make sure that you can sketch a wave of a given phase difference and state this.